2 answers. Continuing along, let's take a look at problem C. In problem C, we still have something similar, even though it looks more complicated. We have a 4x plus 1 squared equals 20. And the idea is we do have something squared. It is by itself, so you can still do the same thing. You can take the square root of both sides. Just don't forget your plus or minus symbol. Because it's squared, you should still have 2 answers. Remember, the square root and squared cancel each other out, but it's not just an x under now. It's a 4x plus 1 that's still going to be there. Equals, we still have our plus or minus on the right-hand side, and we still have a square root of 20. We're getting there. Continue solving this as if the square root of 20 weren't there. The next thing you would do would be the same thing you normally do with an equation, is subtract 1 from both sides. So that would give you, let's see, a 4x, because the 2 1s would cancel, equals plus or minus the square root of 20 minus 1. Last thing you would do is divide both sides by 4, getting there, which would give you that x equals plus or minus the square root of 20 minus 1 all over 4. And this answer is almost exactly perfect, other than one thing. The square root of 20 is we can break down 20 into 2 pieces, one of which you can take the square root of, so that is what we want to do. So we can break down the 20 into 4 times 5. Then we can take the square root of 4. So let's see what that's going to do for us. So taking the square root of the 4 will come out of the square root as a 2. However, you cannot take the square root of 5, so that's going to stay inside of the square root. We still have a minus 1, and the whole thing is all over 4. Now, I know a lot of students want to reduce the 2 and the 4. You cannot do that unless you can reduce everything by a factor of 2. And your problem that you cannot reduce by a factor of 2 is this 1. Everything has to be reducible by your factor, not just 2 pieces. That's why it's written as one big fraction. So what this does is gives us 2 answers. Positive 2 square roots of 5 minus 1 over 4, and negative 2 square roots of 5 minus 1 all over 4. 2 answers that are pretty messy, but we were able to do this and nicely. Now notice, if you think back to your algebra courses, this answer looks a lot like something you would get from the quadratic formula. And absolutely that is true. Had you gone up to the original problem, foiled that out, set it equal to 0, and then tried to factor, you would have realized it wouldn't have factored, and you'd be like, oh no, I'm stuck doing the quadratic formula, in which case you would have gotten the same exact answer. It's a lot more work, but it would still have worked. Just to kind of put that as a side note, it would have worked. Taking a look at problem D. In problem D, we've got another similar problem. We've got 5x minus 3 squared equals negative 3. So starting off, we start off by taking the square root of both sides because we do have a squared by itself. Just don't forget your plus or minus. Now, the square root and the squared cancel each other out, leaving us with what was underneath, which is the 5x minus 3 equals, now we've got plus or minus the square root of negative 3. Okay, now continue solving this normally. What we would do next automatically is add a 3 to both sides. And what that does is gets us a 5x equals plus or minus the square root of negative 3 plus a 3. Then we go dividing everything on both sides by a factor of 5. which would give us now that x equals plus or minus the square root of negative 3 plus 3 all over 5. Almost done. There is one small minute thing that you can do, and it does matter and you do need to do it, which is that there is a negative underneath your square root. And in all your algebra courses up to this point, you should have been talking about what happens to a negative underneath a square root. It comes out as an imaginary, an I, so this would become an I. However, we cannot take the square root of 3, so that would stay as a square root of 3. Only the I can come out. And then we have a plus 3. And then this whole thing is all over 5. Remember, these two terms are not like terms, so you cannot add them, you cannot combine them. However, we do end up with two answers now. We've got positive I square roots of 3 plus 3 over 5, and negative I square roots of 3 plus 3 over 5. Two answers, and again, you'd get the same answer if you had gone up to the original problem, which was squared, FOILed that out, moved the 3 over, set it equal to 0. You would have realized you couldn't factor it, so you'd be stuck using the quadratic formula, and you would get this answer. If you don't remember the quadratic formula, don't panic. However, we are going to see it again in this chapter and throughout the entire course. So you should be up on your factoring, you should be up on your quadratic formula, and we're going to also talk about completing the square. Now, before I actually complete the square, I'm going to actually want to get rid of